Third-party content has been copied and communicated pursuant to Part 5A or 5B of the Copyright Act, unless indicated otherwise.
So, no. All right. Yeah, thanks for coming along today. Yeah, I'm Dean Wern from GHD, the Structures and Materials Manager for Victoria. So I just thought I'd provide a bit of an intro and then get Catherine, our architect for the project, to talk a bit more on Leopold. So we've got a lot of slides to get through, and so I'll try and sort of scoot through it fairly fast and get into the interesting component of Leopold Community Hub. Just a bit about GHD. We're a global company offering architecture and engineering and environment services, so that gives us the benefit with BIM to provide an integrated model where we can put all the services in the one model. There's a few things we'll talk about later on. So I'm fortunate I work across the road in our Geelong office there, of about 50 staff, and Catherine's from our Melbourne office. So what is BIM? BIM is basically a process to try and integrate design and use the information beyond design to go into facilities management and construction planning through to refurbishments and demolition. So it's basically trying to get away from the drawings, the hard copy drawings that are 2D, and once something's built they go on the shelf and they're never seen again. So it's trying to benefit clients by doing more with information that you use and source throughout the design process. I guess we use the term building information modelling, but probably I guess at GHD we've got a lot of civil and transport and projects that even landscape projects, might be environmental projects that aren't buildings, that we use models to integrate information on, so that you can give a client a model. They might click on a river or something, and information comes up on water flows and the like. So it's something that can be used a lot across a lot of sectors, and it doesn't really have to be a physical asset even. So it's probably something that's transferable in skills to other areas. At GHD, we use Revit primarily in the property buildings team as our tool to assist with design, and then the challenge is integrating all the other design packages that you need. So one of the things that we do have working well is the Revit server. So essentially we can have people in, for this project for instance, we have people in Morwell, Melbourne, Geelong. We had a little bit of work done in Manila. So everyone can work off a live model, and you can have the structural, the building services, the architecture, all on the one model. So as things are updated, everyone can see, they can run clash detection, and it's getting away from where different practices send models back and forth, and you've got to check models, you've got to send it back, 2 weeks later another model comes through, you check it again. So really trying to integrate the design process through all the services that feed into a design, and then also capture that in the model so that we can hand it to a client and then try and drive that information into their asset management system. So that's the big challenge. There's not many projects that's been done well. We have a few examples, and often it's the more sophisticated client that actually benefits from that front end work anyway. It's good Autodesk is here today because we've got the different packages we use. You still need to, for civil design, you still need to drag that into the Revit model, or vice versa, use Navisworks, put all these models together, and then you've got your real model with everything in it, from landscape architecture to civil to building services. And it's still a pain. We've got a couple of people from GHD there who've gone through the process, and when we can get everything in one design model, I think we'll be very happy rather than using 5 or 6 different packages. Just some of the tools, you've probably been through this before, just clash detection, programming and estimating, so we can get models, quantities out of the model quite easily. So it's basically just exporting quantities of steelwork and cladding or whatever quantities you need, just to help with the quantity surveying process. So where we're generally operating with BIM, for most companies I guess at the moment, is the conceptual design, detailed design analysis. So we can use heat load analysis that integrates with the model, or structural analysis. So you update member sizes and the structure and the architectural model. In fact, you really only draw it once, so things update rather than trying to do structural drawings and architectural drawings separately. And then through to fabrication, this is where the building information modelling part is probably in its infancy in Australia, I guess, to some degree. Then sending the information model to, say, steel shop detailers or mechanical services fabricators, and using that. It's probably, the contracts have a lot to do with how you can use the information and the risk associated with some of this. And that's where I think in Australia we're still working through a lot of those items. A lot of models get sent out with a lot of words around don't rely on this and that and whatever. And I think through a more collaborative approach we can probably improve how we use things for everyone really. Construction planning, so Catherine's got a bit of a video later on showing how you can use construction planning and staging throughout projects. And then into operation and maintenance, so a lot of clients with larger or a property portfolio will have an asset management system where you can ideally use the information in the model, extract it, so you'll then have all your plant and equipment schedules will come through, all your servicing schedules. You'll know exactly what wall area you've got, so every time you have to paint it every 20 years, you know what it's going to cost you, and things like that. So yeah, and that's the challenging part of BIM, I think, is probably fair to say, is that using it beyond the model and into asset management. And probably the next slide is, I think it's this one. Yeah, so the interesting thing, you go and build a building, it costs you 10-15% of the overall cost of a building, and everyone thinks, oh, this costs a lot and we don't want to spend a bit on this, or we'll cut some corners here. And then through a life cycle of a building, 80% of the cost is borne through the life cycle of the building. So what you can do up front, in the upfront sort of 10-15%, you can really save money over the life cycle of building by being smart up the front and reducing operational costs and the likes. So on that note, I'll hand over to you, Catherine, to talk on the Leopold Community Centre.
Close to the microphone. So the Leopold Community Hub is a project in Leopold that we did for the City of Greater Geelong. It's about $9 million in value, and it's currently under construction and should be completed by the end of the year. So it's stage one of a two-stage development. The first stage is primarily the children's centre, including daycare and a kindergarten, maternal and child health facilities, community facilities like meeting rooms and a toy library, and playgrounds, and also it is a showcase of 5-star equivalent design for Green Star. GHD were engaged for full services on the project, which included master planning, community engagement, stakeholder engagement, and a whole design package including architecture, structural engineering, civil engineering, landscape, all at MEP. And then we also did acoustic engineering, some ESD engineering and analysis, traffic engineering, and we also had sub-consultants to give us some DDA advice. So as Dean mentioned before, the model was kept on the Revit server, so there was one model that was used, was accessed globally from a number of offices across the GHD network. So this model was always live, so as soon as the Revit model was synced by anyone, that meant that someone, if it was in the Melbourne office, in the Geelong office, in the Manila office, could always get that live model and see the changes. So it proved really, really, really efficient. It's really quick, and it was as though even if someone was working thousands of kilometres away, that they were still sort of sitting next to you because they could still get those updates. So most of the actual design was done in Melbourne and Geelong, and then we had some of the Manila team set up drawings, do sort of more of the tedious parts of the project, revving up things, setting up sheets, setting up views, all of those time-consuming things that were quite simple to convey to someone where English might not be their first language. So the Leopold site is on Kensington Road in Leopold. It's where the big star is. So Kensington Road is on the eastern side, and there's a street called Vicarage Road on the west. To the north of the site, it's all residential Zone 1, and to the south is Leopold Primary School. It's also to note that the site has a significant fall from the east to the west, and on the western sides you can might be able to see two imprints, which are two retention basins. So the site's actually on an overland flow path, and it's subject to some flooding. The soil is actually also really bad, which was a big part of our design, especially the structural design. And the school actually next door initially wasn't built properly and had to be rebuilt because the soil was so reactive. So we had to go for some 6 metre long piles underneath the slab, which I'll show you later, which was built in the Revit model. So we used Revit for everything in architecture. So from a very diagrammatic stage in concept planning, we did all these diagrams in Revit. So it was really good because usually we'd do these diagrams in InDesign or Illustrator, maybe Photoshop or even AutoCAD, and then have to redo them again in whatever documentation tool we're going to use. So it was really good that we could start the project in Revit and do the whole thing in Revit. It was much quicker, and the client really appreciated our efficiencies. This is sort of the plan of the building, which we've turned quite a few things off just to make it a bit simpler. But basically, we divided the building into 4 split levels as the building falls down the hill. And the idea, when I show the 3Ds in a moment, was to keep the building quite domestic in scale so that it wasn't too overwhelming for kids and it fit within the surrounding environment. To the north of the buildings are playgrounds. So there's 5 playgrounds and there's 5 sections of the buildings over 4 levels. At the front end, there's mainly community meeting rooms, maternal child health, some office areas and a toy library. And then as you move through the building, there are a series of childcare rooms and kindergarten on the northern side, which is, there's a spine going through it, which is the main corridor. And then on the south side is mainly services areas and a commercial kitchen and some office areas. So these are some views that we quickly modelled up in Revit. So normally, before we used Revit, we used to do something like this in SketchUp and then re-document it in AutoCAD. So from those diagrams, we were able to quickly extrude this model, and we actually use these drawings to show the client and community in the engagement process and for town planning. So as you can see, these are our little pavilions that fall down the hill. This is the second one's from the car park side, so it's looking south. From the Revit model, initially it was also really, really quick and easy to extract areas. So basically, you can automatically, in Revit, you can select a room and then you can quickly schedule it out and it gives you the area. So we were able to give all of these areas to the QS, so they priced it straight away. It was really quick and accurate. And then as we went through the project and put more information in, we were also able to update all these schedules with more information to give to the QS, such as what type of cladding are on all of the walls, so they could quickly calculate the area and then price it. So it was, working with the QS was really easy. It was really good for us and for them. So here are some of the town planning drawings that we extracted just straight off the model. So all we did was create elevations, tag what materials we wanted, and then we were just able to submit this for town planning. So it was quick and accurate. We never had to redraw anything, and instead of using a series of programs, we were able to keep it all in Revit. So, as I said before, this building was a showcase of, it was a 5-star Green Star equivalent design, a showcase for Geelong City Council to use as a building. They want all of their new buildings to be environmentally friendly. So our ESD engineers were able to quickly cut sections out of the model and then analyse them using IES and other programs in terms of daylight, area analysis to work out and make sure the orientation was correct, work out and calculate overhangs for shading, work out what type of glazing we needed. So it was really quick and easy for them as well. So with the actual model, this is what it looks like when we finished the documentation. All of the structural engineering, architecture, services guys, and the civil has been linked into this. And now I can show you. I'm going to split out the different disciplines and show you what each one looks like. So this is structural engineering. So as I said before, it's on really reactive soil. Now structural engineers might correct me here, but they're 6 metre long board piers, or piles, piers, same thing. So you can see all of these long 6 metre piers underneath the slabs. So it's quite cool when you separate out the work sets and you can see how much work goes into all of the framing, the steel work, the slabs, and what's under the ground as well. So this is a mechanical work set. So it was really useful for mechanical because the building fell down a hill. The ductwork had to snake down the building, and it would have been really hard if we did this in 2D flat drawings, because we had to work out how the ductwork was going to fall with the building and calculate how big each bulkhead had to be. So it was really good to see it in 3D straight up. We did work out that as we designed it, that we didn't have enough space for some of the ducts, and we wouldn't have never picked it up unless we did it in 3D. This is the hydraulic work set, so all the pipes that run from fixtures and sanitary fixtures into other pipes. This is the electrical work set. So there's one large cable tray that runs through the spine of the building, and again, like the mechanical, some of the mechanical issues, it was really, really useful with electrical because this cable tray was really hard. We wanted to hide this cable tray within the space as the building fell down the hill. And in a 2D world, it would have been so hard to work out the heights and how it was going to twist and turn down the building, and it was really good to see it in 3D straight away. And our engineers were able to do it really quickly, and the architects and everyone else working the model were able to see exactly what was going on the whole time and if things were in the right position or the wrong position. Some of the other really useful stuff that Revit can do. So Revit can basically be as intelligent as you want it to be. So every object is called a family, and I've just extracted a few examples of how intelligent we can make some of these families. So we have a unisex WC. So in here we've got a disabled toilet, which I've highlighted in blue. And then these two tables show how much information you can actually put into this toilet. So you could either just call it a disabled toilet, you might give it a size, but you can also then go and say what type of tapware it's got. You could put in the cost of the item, the supplier of the item, all these different parameters, and then you can schedule out what you want in different tables, give them to suppliers, you might give them to the QS to cost. Basically, you can put in as much information as you need. Here's an example with some doors. So doors are quite complex, and we could put things in such as the height and width of the leaf, the thickness, the frame type, if it has a fire rating, a view panel, what type of hardware it has, how many hinges. We can schedule out all of this stuff into a door schedule, which we did. So this is just using data off the model, and this was generated really quickly. We then were able to give this door schedule to a hardware supplier, like Lockwood, and they were then able to fill in their items, so putting in the brands of the hinges, the handles, all of that stuff, and then we could then suck in their information into one big table and then give it to the builder as a consolidated table. So rather having bits and pieces of information from different people, we were able to give one table that was really easy for the builder to work with. This is just another example of one of the electrical items, a motion detector in the same bathroom. So every object, no matter what discipline, can have as much information as you want in it. So in this motion detector, we can put in the brand, the size, can even put in when it needs to be replaced, anything like that. You can add as many parameters as you like. This is another example of a fan coil unit in the mechanical work set. So this is a rendering that we did. Now, we didn't use Revit to do the actual rendering. We used those initial 3D concept drawings that I showed you. But basically our 3D architectural illustrator was able to grab the Revit model and then quickly work up these renders in 3D Max. And I've been told that it's really easy to apply materials in 3D Max by using the Revit model compared to something like SketchUp, and it's a lot quicker. Here's another couple of views that we did. So we did these for community engagement. One of them's on the board if you drive past the site. And for town planning, I think. Well, maybe not for town planning. Can't remember. Anyway. Here's just a couple of construction photos. Thought I'd put a few in. So that's from the front from Kensington Road. So here are the posi struts, which look quite cool. And that's for just a straight shot. So hopefully there's actually a site visit tomorrow, and I think most of the steelwork's actually gone up. So unfortunately I couldn't have a more updated photo, but anyway. So some of the advantages that we found with using Revit was that it was one model that was fully integrated, that was always live. It was really well coordinated. So we're 6 months into construction, and we've only had 25 RFIs so far in total. So there's been hardly any issues from the builder because it's been so well coordinated. So we've been able to see what clashes before we give it to the builder to reduce any sort of problems and queries later on. It's also a lot more accurate than, say, using CAD. So, for example, with the structural engineering stuff, the structural designer, the drawings in CAD would often just be within 200 mil, I think, of where you'd place a beam. And in Revit, you have to be really accurate so that if you place a beam in the wrong spot or slightly off, it'll show up in every single drawing that it's wrong. So it's not just your drawing you have to care about the model as a whole, so it's quite accurate. And it's also really easy for the builder to set out the building. So with the setting out of the building, we basically gave the builder an exported site plan. So it was exported into a DWG, and from that they gave it to their surveyor who set the building out. We had no RFIs at all, or any queries about the setup, which was normally we get a few, so it was really accurate and really well coordinated. Another really good thing about Revit is that we could send the model to the builders, who were then able to give it to the shop drawers to do their shop drawings off. So they rebuilt their own model using their own programs, and then we were able to check their model against our model, particularly for some of the structural items, and see whether they were correct or not. It was really quick for the fabricators to produce their models because they could easily understand the building in a 3D form, and it was a lot quicker for us as well. So here's just a markup of, these are some of the shop drawings for the posi struts. It's an example of what they produced and some of our markups. This was one of the first projects that I did in Revit, and that our team did in Revit as where it was fully integrated between disciplines. So we have learnt quite a bit from the project. We did have some problems, especially with resourcing, where quite a few of the older guys that did some of the detailing weren't familiar with Revit, and they were a bit hesitant to learn it. So they did a lot of the detailing in AutoCAD, but we were able to link these into the Revit model, which was reasonably okay. However, there were a few discrepancies between the Revit sections and some of the AutoCAD sections, so we had to really double check things. We are improving these workflows at the moment. We're also trying to improve how civil and landscaping are integrated into the Revit model. So the civil's done in 12D and the landscaping was done in AutoCAD. So we're trying to work out how to link these models in efficiently so we don't have to always, so it acts more like an XREF in CAD rather than having to manually relink the files every time. I just wanted to show some videos as well of what else is possible. So this is another project. This is a simulation that we did for the Craigieburn train wash, and this was done in Revit, and we basically gave the train drivers an instruction manual on how to use the facility to wash their trains. So I'll just show you a quick video on this one. No? Oh, sorry. So this was their instruction manual. Basically, the driver is driving the train. Shows where the train should stop. Need some music. Tells them the rules. And then it shows how the train sort of is washed. I won't show the whole thing because it gets a bit boring. So some other stuff that's possible. We did a large project in Perth for the CityLink project. With that project, it was a really complex building with a lot of, a really complex design with a lot of underground tunnels for this new train station and roads, I think it was. And basically, in order to establish an existing model, we got a point cloud of the existing Perth train station, which is basically a 3D laser scan that then you can link into Revit and form an existing model. So I'll just show you what that looked like. So this is the laser scan, and then we linked this into Revit and had the existing model. And in fact, I was told today that there's a file that's of really high resolution, and all of the colours and everything comes out in the building. It's quite cool. We're also currently working on ways of working out how to compare what was briefed to us is correct in the model. So, for example, in some projects, let's say in the brief we needed 100 chairs, type A chair. There are ways in Revit where you can validate that number of chairs in the model, and then you can see the discrepancies between what was briefed and what you've built. So we used it on a project called Sir Charles Gardner Hospital. Other things that are possible that are in Revit is engineering analysis. So at the moment our mechanical and ESD engineers are using IES for daylight modelling and energy modelling, but I also believe there's the potential for structural analysis in Revit, which will be really good for the future. Collision and clash detection. So when we run these reports, we can see what doesn't work before we give it to the builder, which can be really useful. And also, as Dean talked before, the possibility of giving the Revit model to building owners for them to develop their facility management systems. So things like the mechanical system, that'll all be scheduled in there when it needs to be replaced, what it is, what the brand is, how much it costs, so they can keep accurate records of these and up-to-date records and continually update them. So yeah, BIM is the future. I've got one final. This is a project that GHD did, and it just is a little snip of the building basically being built, and it's all in Revit. So this is what is possible.
Programmed out at the front before they built the building, and then you could actually see what the construction program would be. So that was. So it allowed them to work out when they bring certain materials on site, which way they should build it. So they start from the back of the building, they start from the front, what the layout areas are and things like that.
It's very cool. Yeah, that's it. Thanks.